Okay, so last time we talked about how x to the first power is called a linear variable, right? So the fact that it's linear means that it has the power of 1, nothing else. So if it has a power of 2, it's called quadratic. If it has the power of 3, it's called cubic. Today we're going to look at equations where you have x squared. All right? So, and I'm going to show you a few solving techniques and how you could address these equations. Let me start with example number 1 in the notes. My voice is not working today. Okay, so this is number 1 in your notes. The equation I gave you is x times 2x plus 1 equals 15. Now, looking at it like this doesn't look like a quadratic equation. Every x you see is to the first power. But the reason this is considered a quadratic equation is because before you get to solving, you need to get rid of the complication, right? So here we have a pair of parentheses that need to go away. So to get rid of this, what I'm going to need to do is multiply this x, just like any other number. This just happens to be a number you don't know. So I'm going to multiply this x into the pair of parentheses. So when you do that, you end up multiplying the x by 2x, and that's where you get the power. Make sense? So if I multiply x times 2x, you get 2x squared. Yeah? And x times 1 is just x. So now the equation is 2x squared plus x equals 15. So now we have quadratic. So when it comes to solving any equation, usually the easiest way is to try and set it equal to 0. So in this case, to manage that, I'm just going to move the 15 to this side. So if you do this, you end up with 2x squared plus x minus 15, since it was positive, and we moved it so it turns negative, minus 15 equals 0. Right? Once we get to this point, you can start factoring or using the quadratic equation, which I'm going to teach you later on. So right now, let's just use factoring. All right? So if you remember, I showed you an example of a quadratic while we were doing 1.2, and I talked about how quadratic is basically a multiplication between two pairs of parentheses, which you can technically see here, right? So this one just happens to be x plus 0. So it's its own pair, but it just happens to be one term. So that's the one value multiplied by another pair, which is what we have here. However, you can't factor this to that because these two did not include the 15. I moved the 15 in here, so I have to refactor from scratch. Make sense? So because I've seen that mistake happen. People just think, okay, since I multiplied these, that means that this is that again. But no. So first thing you do, you need to split the x squared and place it in both pairs of parentheses. Now, since the x squared has a 2, you need to factor this 2 into two values. Now, 2 is a prime number. That means that one of them has to be 2 and the other coefficient has to be 1. So we have 2x and 1x. When you multiply them together, you get 2x squared. Okay, now I need to figure out the number that goes here. Let's look at this value right here, 15. That number is the result of the multiplication between these two numbers. And it's negative 15. So that tells you the numbers are 3 and 5, right? Now we need to figure out which one goes where. And that's where the x comes in. But hold on. Since the 15 is negative, that means the sign of the 3 and 5 are different, right? So if you had two negatives, you have negative 3 times negative 5, that gives you positive 15. And if you had two positives, that still gives you positive 15. The only way you'd get negative 15 is if one of them is negative while the other one is positive, right? So if you multiply these two, you get negative 15. But it could also be the other way around. The 3 is positive and the 5 is the negative one. And that's still negative 15. So which is it? And which one goes where, right? Now look here. We have x, that's 1. This number right here is supposed to be the result of the addition between the two numbers. But in what world can you add negative 5 and positive 3, or negative 3 and positive 5, and that would give you positive 1. Doesn't work, right? That's where the 2 comes in. Now here's the rule. The coefficient of this x, yeah, coefficient of that x gets multiplied times the number you're going to put here. And the coefficient of this x gets multiplied by the number you put here, right? So 2 lines, 1 line. Outer, inner. They go like that, okay? So you apply this multiplication before you do the addition. Now, if I multiply 2 times 5, that gives you 10. 3 times 1, that's 3. No matter which one's negative, an operation, addition or subtraction, between 10 and 3 is not going to give you 1. So that's the wrong arrangement. If I put 3 in here, that's 2 times 3 is 6, and 5 times 1 is 5. Now this one works. That would give you 1. So 3 goes here, and the 5 goes here. Now I still need to figure out the signs. After multiplying it 2 times 3, and it giving you 6, the only way adding 6 and 5 should give you 1 is if the 5 is negative. Oh, I think the camera froze. Oh, there we go. Is if the 5 is negative, right? That means that this right here is the negative 5, and that is the positive 3. Is everybody with me so far? Yeah? Okay, good. Awesome. So now you have your 2 pairs of parentheses. So what I'm going to do is set each one equal to 0. Okay? So you grab the first pair, which is 2x minus 5 equals 0. I'm going to write an or over here. For x plus 3 equals 0. All right? Now the first one, we need to solve for x, for both. We'll start with this one. I'm going to grab the 5 with the negative and move it to the right side. It's going to turn positive. So you end up with 2x equals 5. Divide by the 2 to isolate the x. And x is 5 over 2. Okay, that's the first value. Now let's try this one. X plus 3. I'm just going to grab a 3 and move it to the opposite side. And you end up with x equals negative 3. Nothing else to do on the x side, so we are done. The second answer is negative 3. So which one's the answer? Is it 2.5 or negative 3? It's both. Now, I want you to notice something. Do you remember the types of equation I told you guys about? We said we had 3, right? There was conditional, identity, and contradiction. Right? So these types apply to any kind of equation you're dealing with. When we were talking about linear, we said a conditional has only one solution because the equation was linear. When it comes to quadratics, a conditional equation has 2 solutions. So now let's amend the definition of conditional and say it has the n number of solutions. This has, oops, let me do an arrow instead. Okay, there you go. This has infinitely many solutions, and this has 0 solutions. All right? The first one I said n. Why did I say n? I'm going to qualify that and say n is the power. Make sense? So this is the highest degree. That means that the conditional, the number of solutions you get for that type of equation is the exact same number you have for as the power of the equation. So as a result, let's conclude. If we have a linear, we're going to have 1 solution. If we have a quadratic, we're going to have 2 solutions. If I give you a cubic, how many solutions are you going to have? 3 for the conditional, because you have 3 powers. That means you have 3 x's multiplied together. There are 3 values. If you had x to the 4, it would be 4 answers, and so on and so forth. Does that make sense? Okay, good. All right. So let me give you another example. Here's number 2 in the notes. Question says 24 times x squared equals 8x. Okay, that's my problem. Now, we said the first step you should try to do when you're solving quadratic is set one side to be 0. In this case, to do that, I'm just going to grab the 8x and move it to the other side. So you end up with what? 24 x squared minus 8x equals 0. Okay. Now what do you think we should do? You could try and factor, but there is an easier way. A way where you're still factoring, technically, but you're doing it in a more direct manner than drawing the two pairs of parentheses and working it out. Because you don't have an integer right here. You don't have a result of the multiplication between the two numbers that are supposed to be inside the parentheses. This tells me that at least, yes, but it's not a number, not just a number. You factor out the common variable as well. So over here, since I don't have a number, that tells me that one of the two parentheses doesn't have a number added or subtracted from it like these two. So when you see an equation where you only have x's, no numbers, right? So I have 24x squared and 8x. I don't have plus or minus another number. So what I'm going to do is factor out the x itself, right? So if I do that, the first term becomes x to the first power, and the second one just turns into a number. Now, you only factor out the x if that's the only thing they have in common. But since we have a 24 and an 8, they do have something in common, right? If I factor out the 8 as a whole, 24 divided by 8 is what? It's 3. So I'm factoring out 8x. Now, when you factor, you're doing the exact opposite of multiplying what's on the outside inside. So when we do the multiplication, you multiply this to both terms. When we factor it out, what you're doing is dividing both terms by that value. Make sense? So 24x squared divided by 8x, the x squared becomes an x, and the 24 divided by 8 is 3. Okay? Now over here, 8x divided by 8x is 1. So the reason I want you to make sure you know that you're dividing is because I don't want to see a 0 here. 8x divided by 8x gives you 1. Okay? So factoring out the 8x becomes 8x, pair of parentheses, 3x minus 1. That's the factored form. One of them just happens to be an x instead of having a number with it. Make sense? I don't have any value added or subtracted from this x. Now, let's set it equal to 0 because it's still equal to 0. Now I can solve for x. This is your first term. That's your second term. So it's either 8x equals 0, or it is 3x minus 1 equals 0. So for the first one, since the other side is 0, x itself is 0 because it's a multiplication. I can divide by 8 on both sides, and the 8's cancel here, but 0 over 8 is still 0. All right? Here, we solve. You grab the 1, and you move it to the opposite side. That gives you 3x equals positive 1. Now, divide by 3, divide by 3. These cancel, and x equals 1/3. So here's a question. Since one of them turned out to be 0, does that mean I only have 1/3 as an answer? No. 0 is a valid number, and it is a valid solution. So the solutions for this equation is x equals 0 and x equals 1/3. Okay? Those are your two solutions. Any questions so far? Now, did you notice how I was talking about setting everything equal to 0? Because this is called the zero product. Now let me give you a little rule to follow. It says if m and n, right? So these two letters are multiplied and they're variables. You don't know what they are, but they're supposed to be numbers, right? Kind of like x and y, but I'm calling them m and n, right? So if a multiplication between m and n equals 0, then either m equals 0 or n equals 0, which makes sense, right? If one of them is 0, the product is obviously going to be 0. Now, why is this a rule if it's so obvious or so logical? It's because that's what we use when we try to figure out the x's. Since we have a multiplication, see this? This is a multiplication between two terms. So this is your m and that's your n. That's why we try to factor the quadratic. You want to get it to a point where it's a multiplication of two values and the result is 0, so that you can separate them and solve them separately. Make sense? So you either set that one equal to 0 or that one equal to 0, which we did, and then you solve. Does that make sense? So this is called the zero rule or zero product. Okay? That's one way of solving quadratics. Now let's introduce you to another one. Here you go. Now, another one is called the square root property. So what do I mean by that? I'll give you the rule first this time. It says if x squared equals k, where k is just a number, all right? So I'm just saying x squared equals any number. Then x equals plus or minus the root of that number, which makes sense, right? If it's squared, that number, that means that the 1x is the square root of it, because multiplying this twice gives you the x squared. Yeah. So for example, if x squared was 4, that means x is 2, because 2 times 2 is 4, which is what x squared was. But what you need to notice also that I'm saying it's plus or minus, because when you square a value, you get rid of the sign, right? So if I'm removing it, or removing the square, by applying the square root, you need to think about the possibility that that number could be either positive or negative. So you need to apply both. Okay? This is not saying it's both positive and negative. It's saying it's either positive or negative, or both. It depends on the situation. So let me give you an equation and show you what I mean by that. This is number 3. For example, you have 3x squared equals 12. All right, that's simple. First thing you need to do, divide by 3. So divided by 3, and x squared equals what? 4. All right, yeah. So now I want to take the square root of both sides. So you end up with x equals 2. But remember when I told you that any quadratic is supposed to have how many solutions? 2, right? This is just 1. Where's the other one? It's -2. Because remember, a conditional equation is an equation where at one very specific value, yes, there you go, positive or negative, one very specific value is going to solve this equation. So for this equation, the original one we looked at, in order for it to work out, x can be either 2 or -2. It will still work. Make sense? So instead of writing it like this, I could just say x equals positive or -2. They both work. Make sense? So I'm saying that both of them are answers, but I'm not saying that the 2 is both positive and negative. It's just there's 2 values. Yeah? Okay. Let me give you another example. I'll do it here. This is number 4. So you have x squared plus 25 equals 0. Now this is a fun one. I want to see if you guys can spot it. There's an issue here. Can you tell me what it is? I'll give you 1 minute to do that. Right, okay, so if we subtract the 25, I'll do that. It becomes negative 25, right? Because I'm grabbing this and moving it to that side. Yeah? All right. So I'm saying x squared equals negative 25. What's the issue here? Why is negative 25 a problem? Can't square root, but even if you could, like if I give you complex numbers, you technically can. But the thing is, it's not possible. Because in order for x to be squared, that means that that number was multiplied by itself and it should give you negative 25. Anything you square, anything you multiply by itself, even negatives, should always give you a what? A positive result. It can never be negative. No. If you multiply negative 5 times negative 5, it gives you positive 25. And if you multiply positive 5 and positive 5 is obviously positive 25. If you multiply negative 5 and positive 5, you will get negative 25, but that's not squaring. You didn't multiply the same value. One was positive and one was negative. Make sense? So to square something, you have to multiply by itself. They have to match. So when they match, it will always be positive. It will never be negative. So this can't work. Right? Now, that means it has no solution. Now, if I wanted to show it to you from another perspective, I could say, okay, if I want to do complex numbers, which, by the way, is the way it's solved in the notes, but since I'm not planning on teaching you that, that section, this is the solution you care about, right? The answer is no solution. Now let me show you another example. So here's number 5. And it says x plus 7 squared equals 8. Now this one, I gave you a pair of parentheses and I squared it. What do you think we should do first? You want to get rid of the complication, right? Since it's not just one value that's being squared, it's 2, it would be ideal if I could get rid of the square. So we just apply the square root. That's the simplest way of dealing with this. You square this one and you square that one. So squaring a square, they cancel, right? And you end up with x plus 7. On this side, though, you have positive or negative root of 8. Now, square root of 8 can be simplified if you want. We can write it as, for example, 8 is 4 times 2, right? So this is the root of 4 multiplied by 2, which basically means it's the root of 4 multiplied by root of 2, because multiplication under the root can be split. Now, root of 4 is answerable. This is what? 2, right? So I'm saying it's 2 root of 2. I don't care really if you do that simplification, but your homework might. So I wrote it out. Okay? Now, I'm saying that x plus 7 equals positive or negative 2 times root of 2. Now, move the 7 to the opposite side, and it turns negative. So we have x equals negative 7 plus or minus 2 root of 2. So how many solutions is that? How many x values do we have? There's 2 here. It might look confusing because we have so many signs, but I'm basically saying x equals negative 7 plus 2 root of 2, or negative 7 minus 2 root of 2. Make sense? Okay. Now to the fun part of the lecture. I actually like this part. Did anybody ever hear of a way of solving called completing the square? Yeah? Okay. So that's what we're going to do just now. So those two were the simplest forms of solving. Not the easiest, though. The easiest would be the quadratic formula, which we're going to get to towards the end. But here's another one. This is one that's called completing the square. It's when you want the quadratic equation to be in the form of a complete square. Now, what's a complete square? A complete square is when you have ax squared plus bx plus c equals 0. When you have this equation, this is like a standard quadratic form, right? So it's when the quadratic form can be rewritten in the form of x plus or minus a, or maybe I shouldn't use a. Let me use another number, n, because it could be anything, n squared, right? So the idea here is that I want this quadratic to be written in the form of a pair of parentheses being squared. Make sense? That's called the perfect square. So when we encounter an equation, I want to manipulate it to make it look like that. And that's what we're going to learn how to do. Now, in my notes, I have like steps written out for you. So it would be easier for you to remember while you study. As you can see, step 1, 2, 3, 4. But since we're in lecture, I'm going to walk you through them one by one. All right? So let's start with example number 6 in the notes. I'm going to leave this visible a little bit. Okay, so here we go. Number 6. The example says x squared negative 18x positive 5 and it equals 0. And I've had a student ask me once, it's like, why would I want to do this when I could just, factor? It's because sometimes factoring isn't so easy. For example, you have what? 5. So that's what? 5 and 1. It can only be 5 and 1. And yet the x is what? Negative 18? How is the addition between 5 and 1 giving you negative 18? Right? So sometimes it can be very tricky to do that. So when you encounter those equations, this form of solving can come in handy. So let's try. Step 1. First thing you need to do is make sure that the coefficient of the x squared is 1. In this case, it is. So after step 1, this is the result. Nothing happens. We're good. All right? Now, step 2. I want you to grab the positive 5 here, the number, and move it to the opposite side. Okay? So after step 2, the equation looks like this. Minus 18x. Now, please make sure to leave a room between the 18x and the 0. Oh, sorry, not 0. And the equality sign, the 5. Since it was positive, now it's going to be negative. Okay? That space is necessary because you're going to add stuff in here. All right. Now, here comes step 3. This is the fun part. I want you to look at b, what is essentially b, right? What's b? It's the coefficient of the x to the first power. So the negative 18 right here. This is step 3. You grab the negative 18. I'm going to write it right here. This is outside of the equation. Okay? I'm writing the negative 18. And then I'm going to divide it by what? By 2. Dividing it by 2 gives you negative 9. Okay? And then I'm going to grab the negative 9 and square it. Once I do that, the answer is what? 81. Right? So this 81 right here, I'm going to add it here and here. Okay? Because remember, when we're dealing with an equation, It's an equality between two sides. That means that whatever you do to one side has to be done to the other side. So I'm going to add the 81 to both sides. So again, you grab the value of b. You divide it by 2, you end up with 9. Square that number, and you end up with 81. So it's going to get added here and here. So the final result after step 3, I'm writing the equation now. It's x squared minus 18x, that part didn't change, plus 81 equals negative 5 plus 81 is 76. So far so good? After you've done that, you technically finished completing the square. All right? Now, basically, what we did was grab the value of b and manipulate it, divide it by 2, and then square it, because if you remember, when you're factoring any equation, we say that the last number is the result of the multiplication of the two numbers inside the parentheses. So since we want only one pair of parentheses with the same number, that means it has to be something squared. And since the number in the middle is the addition between those two numbers, it means that whatever number you have here divided by 2 would be the answer inside the pair of parentheses. Does that make sense? So doing this completes a square. Now, if I want to rewrite this in the form of a pair of parentheses squared, I'll put in the x in here, and then you grab the number you squared, which is a negative 9, and you write it in here. That's your complete square. This is the perfect square. So don't take the 18, you take the negative 9, the result of the division or the number you squared. Remember it any way you want to. Just please don't give me the 18 itself or the 81. I've seen people do that. It's the negative 9, the one you squared, okay? Which goes in here, along with its sign. Make sense? So now we completed the square. Okay, so now since we have a pair of parentheses squared, solving this becomes easy. All you need to do is take what? The square root of both sides. So I'm gonna take the square root of this and square root of that. So squared cancels with the square root. And we have x minus 9 equals, don't forget the plus and minus, root of 76. Everybody with me? And last but not least, just grab the 9, move it to the opposite side, and x equals positive 9 plus or minus square root of 76. Now, again, as far as I'm concerned, if you stop here, this is the correct answer. If you want to simplify the root, go ahead. Doesn't actually, maybe I can do that for you here. For this example, 9 plus or minus. Okay, let's look at the root. 76. It's an even number. It's obviously divisible by 2. You could probably divide it by 4, and since we have a 4 under the root, that makes it 2. So 76 divided by 4 is 19, right? So you have 4 times 19 under the root. So that becomes 2 times root of 19. That's the simplest form. And 19 is a prime number, so there's no simplifying that. Okay? Now, again, this is how many solutions? It's 2. One of them is 9 plus 2 root 19, and 9 minus 2 root 19. Okay? Okay, so let's do one more. And I'll try to give you one where we have a coefficient for the x. So we do step 1. Okay? Are you guys ready? How much time do we have? Oh, we're good. Okay. All right, let's see. This is number 7 in the notes. Okay, here we go. So the example says 2x squared minus 4x minus 3 and equals 0. All right. Now, step 1. Make sure the coefficient of x squared is 1. So since it's obviously not, what I'm going to do is write the entire equation over here and then divide everything by 2. You divide every term by 2. And you're supposed to divide the answer by 2, but it's 0, so don't worry about it. Now, the result of this would be x squared minus 4 over 2, 2x, minus 3 over 2, because you can't simplify that. And the answer is 0. This is your new equation. That's step 1. Okay. Now step 2. I'm going to move the negative 1.5 to the opposite side. So you get x squared minus 2x, leave space, equals positive 3 over 2. Yeah, so we grabbed this and we moved it. Okay. Step 3. Now let's play with it. Negative 2. You grab the negative 2. You divide it by 2. This is going to be negative 1. Now, that negative 1, you're going to square it, and the answer is going to be positive 1. Okay. Grab that answer, and it gets added here and here. And the result would be x squared minus 2x, we didn't touch that part, plus 1 equals 3 over 2 plus 1, which is basically 2.5, so 5 over 2, if you will. Okay? Now you complete the square. Okay, I can write this in the form of a complete square now. 5 over 2. So what goes in here? First term is the x, that's easy. Now what number do I write down? It's going to be the number I squared, right? That one. So it's a negative 1. Okay. Next step would be completing. Oh, sorry, not completing square. It's taking the square root. So you take the square root of both sides. Squared with the root cancel. And you end up with x minus 1. And it equals 5 over 2 under the root, and it's positive or negative. Okay. Negative 1 gets moved to that side. It becomes positive. The next is 1 plus or minus square root of 5 over 2. Any questions? We good? Did I lose you guys? Are you here? Oh, good. I thought it was disconnected. All right, awesome. So let's move on to something a little bit more fun. I think you'll enjoy this one. This is what we call the quadratic formula. All right. Let me see if anybody remembers it. Did anyone hear of the quadratic formula before? Yeah? Can you write it down? And for square root, just say squirt and then pair of parentheses to imply what's under the root. while you do that, I'll write the number for the next example. So it is what? It's x b plus or minus okay, of b squared for ac over 2a. That's right. You only have one mistake. It's negative b, which is actually the mistake a lot of people do. Okay, so here we go. To be able to write out the quadratic formula, you need to be very familiar with this form, which is ax squared bx plus c equals 0, the standard quadratic form. Okay, now here's the formula. It says negative b plus or minus square root of b squared minus 4ac over 2a. That's your formula. Now, when I say b, I'm talking about the coefficient of x. C, it's right here, and a, it's right here, and here. Okay, so that's what I'm referring to. When you see b, c, and a, I'm talking about the position of the numbers. That's why we use this. So if I give you an equation that doesn't look like this, first thing you need to do is put it in this form. That's the only way you can figure out what the numbers are, right? Which is a problem we have here. I have 2x multiplied by a pair of parentheses. So that's what I'm going to do first. I'm going to get rid of any complication, make sure this side is 0, and then use the formula. All right? Here we go. 2x multiplied in, one value, two values. Okay, here you go. 2x times x is 2x squared. 2x times negative 3 is negative 6x. It equals negative 7. Next step, grab the negative 7, move it to this side, because I want the right side to be 0. That gives you 2x squared, negative 6x. That part didn't change. You add 7 and equal to 0. Okay, now we're good. Now this looks like that, just with numbers instead of letters. Okay. Now, one thing I always have my student do, you don't have to do it every time, but at least consider it in your head, because it will help you eliminate the possibility of making one very simple mistake. The equation says negative b. So when b is already negative, often students say, okay, so this is negative 6. It's like, no. The idea is that the standard actually has a positive sign. So whatever sign you have is the current positive sign, and you need to flip it every time. So rewrite this equation. Rewrite it like this. 2x squared plus negative 6 times x plus 7. So I'm basically saying I'm adding a negative 6, which basically is subtracting a 6. It's the same idea. However, looking at it like this will help you avoid that mistake, because now you see that b is what? A is 2, b is negative 6. That's the value for b. And c is 7. So when you come here and I'm asking you to give me negative b, what's negative b going to be? Positive 6, right? So if you do this little step every time, you will avoid making that mistake. Okay, so basically the equation saying negative b, you need to flip the sign of b every time. If it's positive, it's going to turn negative. If it's already negative, it's going to go back to positive. Yeah? Now, let's use the equation. Now, here are my a, b, and c. So x equals, first off is negative b. So 6 plus or minus square root of b, which is negative 6. I wrote b instead. Negative 6 squared minus 4 times a, which is 2, and c, which is 7. Okay, the whole thing is going to be divided by 2 times a, which is 2. So that equals positive 6 plus or minus. Now let's deal what's underneath the root. You have 4 times 2 times 7, so that's 4 times 14, which is actually 28 times 2, 56, right? Now 6, yeah, the 6 and negative 6 squared is 36. And it's, so we have positive 36 minus 56. So you get negative 20, that's right. And on the bottom you have 2 times 2, which is 4. So that means we have 6 plus or minus, subtraction between these two is negative 20 over 4. Yeah? Okay. Now, this equals. Can you factor out a 2 out of this? No, because you have a negative root right here, right? So if I want to solve this, because I have a negative, that means you're going to end up with 6 plus or minus 2 times the negative 10 only. And you have a 4 over here. Now I can factor out the 2 out of the 6 as well. So this becomes 2 times 3, right? And I can simplify a 2 out of each one. So you have 2 as a common factor. We have 3 plus or minus root of negative 10 over 4. So 2 cancels with the 4, end up with 2. So you have 3 plus or minus root of negative 10 over 2. That's your answer. 2 values, one positive, one negative. But since we have a negative under the root, you already know that this is going to be complex. But since I'm not covering that section, this is where we're going to stop. Okay? So if this looks different from the solution in your in the notes, is because in the notes I usually cover complex numbers. Okay, let me take a look. Oh, actually, scratched. If you guys felt confused about something, you're probably right. I did make a mistake. Over here we have what? Negative 20, right? And 20 is 2 times 10, is true, but the 2 still has to be under the root. 20 is also 4 times 5, and that's when you can get out of the, get rid of the 2. So in that case, this will be a negative 5, not a negative 10. Okay, so please make sure to fix that. That's a mistake. It's a negative 5. Man, that looks bad now. Yeah, so negative 5 inside the root, not a 10. Okay? But yeah. Now, right now, the fact that it's negative under the root is not really causing you problems because we're just saying that x equals this value. But further along, when we go into functions, then it would be a problem. Like the answer cannot be a complex or a number that doesn't exist. Okay? Would the 2 change to a 4? No, because I removed the root. Make sense? So it's supposed to be the square root of 4 times -5, and then when you split them, you get square root of 4, which is 2. Make sense? So I made that step without removing the 2 again from here. That's why. So yeah. All right, so let me hide my shame. I can't go all the way up, too bad. Okay, now, actually, let me show you. Okay, here's something called the discriminant. This is technically not in your book, but it's really, really cool to notice. It helps you be able to tell how the equation is going to behave way before you start solving it. So I think it's something cool to show you. This is called the discriminant, right? So out of the quadratic equation, which is negative b plus or minus b squared 4ac over 2a, right? So out of this, I'm going to focus on the part underneath the square root. Okay, so the part we're going to study a little bit is the b squared minus 4ac. This one right here. Okay, so I'm not saying I'm going to get rid of everything else. I'm just saying I want you to focus on this, because looking at this value is going to help you spot a pattern, all right? Because it's underneath the root. Now here's why. The first one is when b squared minus 4ac equals 0, right? So that tells you that the value underneath the root is 0. Okay, so since we're solving quadratics, you're supposed to end up with 2 solutions, correct? And the fact that the plus or minus sign is placed before the square root right here, that tells you that this root is essential for you to getting those 2. Because it's going to be the negative b plus the root and negative b minus the root. So what happens when the value underneath the root is 0? That means you have a square root of 0. When that happens, you will end up with only 1 solution. You won't have 2. It will be the same solution twice. Because the negative b is going to be plus or minus 0, which is the same result. So essentially, it will be x equals negative b over 2a. Make sense? Just the one answer. Now, if the b squared minus 4ac equals a positive number, right? So if I gave you something positive, that means that the value underneath the root is positive. In that case, you will have 2 solutions. All right, 2 real solutions. If the value underneath the root is negative, like what we just saw, then you're going to have no solution, or what we call 2 complex solutions. Okay? Any questions so far? No? All right. We are done. But before we go, let me talk a little bit about the homework, the book, and everything else before you log off. And I need to make sure I take roll before you leave so that everybody who's here gets credit. Okay, roll is done. Awesome. Now, the funny walk off. I don't know what that means, but okay. Okay, so here you go. Let me share my screen instead of the projector. Oops, hold on. You said before we walk off. See, I thought I said to get off, but okay. Because I'm bilingual, I speak Arabic and English, so sometimes my brain is thinking in Arabic and the words coming out in English, so it ends up being a very, very strange sentence. Arabic rules and English are like literally opposite. You even read from right to left instead of left to right, so it confuses even me sometimes. Uh, okay, yeah, you're on the screen. Yes. Okay, so because I'm looking at you and you're seeing me looking at you and so on and so forth, so that you get this awesome effect. I actually like looking at this. But anyway, so if you go to the Blackboard, this is where we usually have our class. Click here on the menu in Collaborate Ultra. If you click Recordings, you'll see our previous lecture and this current one. Although just give it time because I researched this after the recording didn't pop up for a few days. Apparently it takes about 24 hours for the lecture to appear. So like we took it today this morning, wait until maybe tomorrow morning before you look for it. It won't be available before then. But yeah, this is where you find the recordings in case you miss class for whatever reason and you need to watch the lecture. You can also just look at the notes because that's what I go over during class. But yeah. Okay, so if you go to course content, come right here. This is your course ID. This is the number you need to enter to enroll in the course on my math lab and be able to access the homework. Also, this is the registration instructions. I have them right here. So if you open this file, you'll be able to see step by step what you need to do to enroll in the course on Pearson's. And if anyone still has any questions, just let me know. I spoke about this a little bit at the beginning of class about the homework, but I'll just reiterate for the people who showed up after I did that. So homework for the first week. Okay, let's try again. Can you hear me now? Yeah? Okay, go. Good. Okay. So I was talking about the homework. So the first week, don't worry about having anything due. I moved everything. So basically, it's like the first week of school never happened. Just the semester started a week late. Now, for the people who can't get their access code yet or still working on it, I moved the due dates for the first 3 or 4 sections until September 15th. So you have plenty of time to make sure you get the code and do the homework. Just if you finally get it, don't wait too long because there are like 3, maybe 4 sections for you to do, and they're all due on the same date, right? So don't procrastinate and make sure you finish those as soon as possible. So there is homework due. I moved the date back. So 1.2, for example, which we took last week, and 1.5 today, and 1.6 is going to be next week. They're all going to be, yeah, and 7, they're all going to be due on the 15th. Actually, I think 7 is due on the 17th. I gave you extra 2 days because I like giving you a week. The book is actually included with the access code. Like you have access to an ebook version, so you don't have to buy it, but you can. It's called Blitzer, the 7th edition for college algebra. It's in the syllabus. If you want to look at the syllabus, you'll see the name of the book under course material. You'll also find my email there if you want to contact me. But you don't need it. Like I don't require you to get the book, just the access code. And since I provide you my own set of notes, like you can study from the notes instead of the book. And one good thing, I guess, that comes out of this situation we're in is that you can rewatch the lecture anytime you want. So looking for the code, where do I purchase it? Right, so you don't need an access code for the specific book, you just need access code to Pearson's My Math Lab. So if you can't get it through Sanjak bookstore, you don't have to try too hard about that. Like honestly, I think that's more confusing than Pearson's. Just go to the Pearson's website. Hold on, let me share my screen and hopefully show you how that's done. Okay, so I'm gonna open a new page and say Pearson, My Math Lab. There you go. Just Google it. Opens the page right here. So this is Pearson's My Math Lab. If you had an account before for any other classes, just sign in. If you're new, register, and when you do, you click Student. Later. Okay, so here we go. This is the registration page. You click OK, register now. So first thing you need to do is enter the course ID. This is from my other class, so it doesn't matter. Copy the one I have on Blackboard for you. So continue. How to go there? Oh, so okay. Fine. Let's do this then. Copy. Oops. Paste. Paste. Did I copy you? No. Okay. Continue. There we go. So if you have an account, sign in. If you don't, you're going to click create. Once you create your account, it's going to ask you to either enter the access code, which you've already purchased, or pay for about 18 weeks of access, and it's like 70 bucks. So you click that option if you don't have an access code, and you pay for it, and that's that. You're in the course. If you have any other questions, just let me know. All right, you guys. Have a fun weekend. Bye.